right, hello beautiful people and welcome. In today's video, we will be discussing transformations of functions. Now this is an introductory video to transformations, so we will be working on a graphic organizer today. Now this graphic organizer is extremely important in this class as we're going to use this organizer for the remainder of the school year, meaning from all the way from now all until in June. It's so important that you have this, keep it, put it in a protective sheet, put it in the front, section of your binder. Please make sure not to lose this because I will be referring to this all the time. So when I say take out your transformation cheat sheet, this is the graphic organizer that I am going to be referring to. Now let's start with transformations of functions. Now what exactly are we doing? Transformations is when something gets transformed. I'm thinking like the Transformer movie. We have and again, don't know the names, so you're gonna have to I apologize, you're gonna have to work with me. You have the car being transformed to the robot thingy, right? So it's transforming. It gets bigger, smaller. We're shifting it. It goes to the left, to the right, up and down. So what we're doing with these functions is we're actually graphing the functions in respect to what has happened, what transformation has occurred. So before we do that, we're going to have to know if it's a cubic function, a quadratic function, if it's a square root function, how these things look like. So make sure you have an idea of what each parent function looks like. So the function is going to be given to you in terms of, let's say, f of x. Now, it doesn't have to be f of x. That's just the most common thing that they use. And they're going to say this is your parent function. So what is happening to that parent function is going to be the transformations. There's going to be two things that I'm going to be referring to. I'm going to be referring to inside the bubble and outside the bubble. So I just want to point that out right now. Here's your thinking bubble. So the bubble I am referring to is the parentheses. So if something is inside the bubble, that means it is inside the parentheses. If something is outside the bubble, that means it is outside the parentheses. So the first thing we're going to do is here is our parent function. And we're going to say, here's our new function, our transformation, so our new function. Let's go ahead and draw a line here. Then we're going to say how the points on the graph how the new points are going to become. Then we have the visual effect. And then I'm going to give you an example. Okay, so what we're going to be working with right now, all of these are going to be outside the bubble. So these transformations are going to be outside the bubble. And outside the bubble is vertical. And it's going to be up or down. So vertical, I'm going to try to squeeze it in. So vertical is up or down. Vertical means on the y-axis. So things are happening on the y-axis. We're going up, we're going down. Change is vertical if it's outside the bubble. So, okay, so here's our parent function. So whatever that function is, we're just using f of x because it is generic. It can be x squared. It can be 3x plus 5. Things are a parent function. So here it is, and I'm going to add a letter D to that. And you know what? Instead of letter D, I'm going to use K. Doesn't matter. It's the same thing as a variable. So if we add K to this, what happens to it? And it's going to shift up by K. So what does that mean for your points? So if you have your original point as A and B, what happens to that? Well, we're shifting it up K amount. So if I'm going up on the y, so that means I'm not touching my x value, but on the y, I'm actually going up by k. So I'm going to add k to my y value. So how would that look like as an example? So let's say we have a parent function of, let's do it here. So this is my parent. Here's my parent, and that is going to be f of x is equal to x squared. That's my parent. This is how my parent looks like. So what happens when I say x squared plus 3? Here's my bubble, right? Here's my parentheses. We don't really see it, but it's there. Mathematicians are lazy. Plus 3 is outside the bubble. So I'm going to shift up by 3. So how does my new graph look like? All of my points, my y value points, are now being lifted by 3 up. So if my original point was at 0, 0, now it's at 0, 3. If my original point was at 1, 1, now it's at 1, 4. If my original point is at negative 1, 1, now it's at negative 1, 4. And it's shifting up vertically. All right, now let's do more examples. We're going to use this x squared as our parent function for all of our examples, just so that I can save some room. Next thing we have is f of x minus k. So what's happening? We are shifting down vertically. So that means my y value is going to be decreased by k. So I am shifting down by k. So if I have, for example, x squared minus 3, let's call this g of x. So that means that my parent function is now going to shift down. I'm just going to pick it up and I'm going to shift it down by 3. Everything else stays the same. I'm just shifting it down. I'm not moving it, stretching it. I mean, I'm not making it taller, wider. All I'm saying is I'm picking it up and I'm shifting it down 3 jumps. All right, next one I have is, let me shift this. There we go. Next one I have is still outside the bubble. All of these are outside the bubble, and that is being multiplied. So if I have c times f of x, again, it is outside the bubble, so that means it's being affected vertically. And that c is greater than 1. So when c is bigger than 1, my y values are being multiplied. So if I have a and b as my points, again, nothing's happened horizontally, so I'm not dealing with any of my x values. I'm only dealing with my y values, and my y values being multiplied by whatever c is. And that's when c is bigger than 1. And that means it is stretched vertically by c. So how would that look like if it's vertically stretched by c? So if we have 2 times f of x, 2 times my parent function, that means I have 2 times x squared. And how would that look like? Well, that just means all of my y values are being doubled. So I am stretching it vertically. That means I am making it skinnier and taller. I'm just making it taller. Multiplying my y values by 2, because that's what I'm doing here. Multiplying the function that is outside the bubble by 2. Let's do a few more. Now I have, what do I have? Now I have 1 divided by c. And that just means my function is, it's a fraction. So if you have a fraction out here, how does that affect it? Well, we're still multiplying by that value. Still multiplying it. However, it's no longer being stretched because we're not multiplying by a whole number. It's actually being shrunk. So we have a vertical compression. Compression, is that how you spell compression? Shrinking. You can say shrink. I usually use shrink. It's a vertical compression by whatever your factor is, in this case 1 over c. So when you have a vertical compression, it shrinks down, right? Vertical compression. So if we have 1/2 times our parent function, and then so that means like 1/2 times x squared. So how would that look like? It means that all of this is now being shrunk, so it looks more like a bowl. It's not as tall. All right, so we have 4 things outside of the bubble. Right now we have plus k minus k outside the bubble. We have times c times 1 over c outside the bubble. And so we have one other thing that's outside the bubble, and that is negative f of x. Now, when you have a negative outside the bubble, you are still changing things vertically. Okay, so the change is vertical. However, in this case, same thing, you know, if c, this is 1 over c, so this is negative 1. So we're still multiplying everything by negative 1. So we're taking our y values and we're multiplying that by negative 1. So what's happening here? This is we are flipping over, or let's not say flip over. This is a reflection. We're more fancy than flip over. Reflection. I can spell reflection about the x-axis. So the change is still vertical, but what we're doing is we're flipping across the x-axis. So if this is our parent function, and we want to flip our parent function, we're going to reflect it across the x-axis. That's our mirror, so now it looks here. Now look at here. If I had a value 1, 1, now the value is 1, negative 1. So we are changing our y, we are changing vertically, just the flip happens across the x-axis. So all of this is outside the bubble. Outside the bubble. Again, please make sure that you're making this graphic organizer super duper duper important. So now let's work on inside the bubble. So inside, the change is happening inside the parentheses, so inside the bubble. Now, if it's inside the bubble, oh, you can't see that. There it is. If it is inside the bubble, that means the change is horizontal. Change is horizontal. So, and inside the bubble, it's horizontal, and think opposite of what you see. Think opposite of what you see. Inside the bubble, it's horizontal. Think opposite of what you see. All right. Let's do the first one. And again, please make sure you're writing this down so you can have this with you forever and ever. So what do we have? We have f of x plus d. We didn't use d last time. We used, what did we use? We used k. Oh, they used h. I'm looking at a cheat sheet here just to make sure that my letters, they used h. Let's do h for horizontal. Okay, so inside the bubble, horizontal. So how does that affect our points? So if this is our point, A, comma, B, that's still our point. How does that change it? Well, here's what I see is opposite. Do you see how this is a plus H? We're actually going to do the opposite of what you see. So if you see a plus H for your horizontal, you're doing the opposite and you are subtracting A minus H, comma, B. Now we're not using our B here because we're not doing a vertical change. We're only doing a horizontal change. And think opposite. If you see a plus, subtract. I'm actually going to jump in and do the other one immediately. X minus h. So again, think opposite. So I have a plus h now, comma b. Always think opposite when you're inside the bubble. Inside the bubble, opposite. So what happens? This is a horizontal shift by by h. But where? What direction? We know it's horizontally shifting because it's the opposite. So do you see how we have a plus? We're not going towards the positive. We're actually going towards the negative, and that is left. Left shift by h. This one is a minus. We are not going to the minuses. We are going to the pluses. We're thinking opposite. So it's a horizontal shift, but we're going to the right. By h. Again, always think opposite if you are inside the bubble, if you're inside the parentheses. Okay, so let's go ahead and I'll do some examples at the end here. Just want to make sure to list them out. Okay, so inside the bubble, inside plus h, inside minus h, again, think opposite. Now we're doing the inside multiplication. So again, think opposite. If this is multiplying x, what is opposite of multiplying x? We're actually going to divide. We're going to divide our x values instead of multiplying. We're doing the opposite. I know it's weird, you guys. So if I have a fraction, guess what's happening? I'm actually going to be multiplying. It's weird, I know. That's okay, math is weird. So what's happening when we divide by a? We're actually shrinking horizontally by 1 over c. And this, since we're multiplying, we're actually multiplying, we're going to stretch horizontally by c. We're doing the opposite. Always think opposite when you are inside the bubble. Last thing for inside the bubble, we have the negative inside of the bubble. And that is, it's just -1, so it's just a fraction. So we're still just doing negative a, or multiplying by -1, all of our x values. And this is a reflection over the y-axis, So let's jump in with examples here. So if we have, again, let's do parent function as a quadratic, just squared. So if we have this one here as my parent, so if we reflect over the y-axis, it stays exactly the same. Nothing changes. So if this is f of x, this is my parent, this is my reflection. Again, reflect across the across the y-axis. This one here, we're going to stretch horizontally. So let's do this one here. Let's multiply it by 2. So let's do f of x, and we're going to do inside the bubble. So we're going to say f of x divided by 2. That's our transformation. So how would that look like? We're going to stretch horizontally. So we're just going to make it into a very big bowl. This one here, we're going to shrink. So we're going to multiply. So I have 2x inside of my function. Shrink horizontally, that means it's going to become more narrow. More narrow if we're shrinking, more narrow. Horizontal to the right, these ones tend to be your guys' favorite. So if I do f of x minus 3, so that means I'm going to the right 3 jumps. So that means here's 1, 2, 3, something like that. And if I do f of x plus, 4, then I'm going to the left 4 jumps. 1, 2, 3, 4. Here's 4. Here's my parent function. All right, beautiful people, that is your graphic organizer. In the next video, we're going to work on some examples. I will assume that you have this in front of you so we can do some translations. Thank you so much for watching, and I will see you in the next video.